Hi everyone, welcome to lecture 20 on basic inorganic chemistry. My name is Dr. Teresa Chimambam. Right, for today's lecture, we will learn how to determine the limiting reagent and we'll learn how to calculate theoretical yield and percentage yield. What is a limiting reagent? During chemical reactions, some reactants are used in excess. When this happens, the number of moles of the reactant that is used in excess will be more than the number of moles of the other reactant that is not used in excess. For instance, in this chemical equation, this is acetylsalicylic acid and this is copper-2 carbonate. Acetylsalicylic acid is in excess because we have 4 here and 2 for copper-2 carbonate. When you calculate the number of moles for acetylsalicylic acid, it will be more than the number of moles for copper-2 carbonate. So the reactant that is not in excess is called the limiting reagent. So in this reaction, copper-2 carbonate is the limiting reagent. The limiting reagent determines the number of moles of product produced. So in this reaction, copper-2 carbonate, the limiting reagent, determines the number of moles of copper-2 asprinate produced. So this limiting reagent, copper-2 carbonate, determines the number of moles of copper-2 asprinate, which is the product. It determines the number of moles of this product that is produced. So, the limiting reagent in any chemical reaction is the reagent that is totally consumed at the end of a reaction. So for this reaction, at the end of this chemical reaction, the whole of copper-2 carbonate must be totally consumed because it is the limiting reagent. Theoretical yield is the maximum amount of product that can be formed from the given amounts of reactants. So, theoretical yield is the maximum amount of this product that can be formed from the given amounts of these two reactants. So, this is what limiting reagent and theoretical yield are all about. So we now learn how to determine the limiting reagent, how to calculate theoretical yield, and percentage yield. So let's have a look at this example. In an experiment, 3 grams of acetylsalicylic acid, and it's abbreviated ASA, was dissolved in 50 ml of water in a beaker containing 1 gram of copper-2 carbonate. After the reaction, copper-2 asprinate, in brackets, this is the short form of it, was produced according to the equation below. So this is your acetylsalicylic acid, this is copper-2 carbonate, and this is your copper-2 asprinate. So you are asked to calculate the theoretical yield and percentage yield. So the first thing you need to do is to determine the limiting reagent. And to do this, we need to calculate the number of moles of each of the reactants. So we need to calculate the number of moles for acetylsalicylic acid, and we need to calculate the number of moles for copper-2 carbonate. So number of moles of acetylsalicylic acid, which has this formula, is equal to mass divided by molecular weight. So the mass for acetylsalicylic acid that is given is 3 grams. So we put 3 grams here. And the molecular weight for acetyl salicylic acid is 180 gram per mole. So this gram, we cancel this gram, and if we divide this, it will give us 0.017. So this mole will come up, so the unit will be in moles. So we have 0.017 moles of acetyl salicylic acid. Now we calculate number of moles of copper 2 carbonate, which is equal to mass divided by molecular weight. We are given that 1 gram of copper 2 carbonate was added, so we divide 1 gram by the molecular weight for copper 2 carbonate, which is 124 gram per mole. This gram cancels this gram. This mole comes up. So the answer is 0.008 moles of copper 2 carbonate. Step 2 is to calculate moles of each reactant from the balanced chemical equation. This is the balanced chemical equation, so we need to calculate the moles of each of the reactants using the balanced chemical equation. For copper 2 carbonate, remember that we already calculated the moles for acetyl salicylic acid to be 0.017 moles. So 0.017 moles acetyl salicylic acid multiplied by 2 moles of copper 2 carbonate. These 2 moles of copper 2 carbonate is from this balanced chemical equation divided by 4 moles of acetyl salicylic acid. 4 moles of acetyl salicylic acid is also from this balanced chemical equation. The reason why we put 4 moles of acetyl salicylic acid here is for moles of acetyl salicylic acid here to cancel out with these moles of acetyl salicylic acid so that we can calculate moles of copper 2 carbonate. So this cancels this, and then we will have 0.017 multiplied by 2 moles of copper 2 carbonate divided by 4. So this will give us 0.0085 moles of copper 2 carbonate. Okay, now we calculate the moles for acetyl salicylic acid using the balanced chemical equation as we did for copper 2 carbonate. So this is the balanced chemical equation. The calculated moles for copper 2 carbonate is 0.008 moles. We did that in the previous slide. So 0.008 moles of copper 2 carbonate multiplied by 4 moles of acetyl salicylic acid. This 4 moles of acetyl salicylic acid is from this balanced chemical equation divided by 2 moles of copper 2 carbonate. These 2 moles of copper 2 carbonate is from this balanced chemical equation as well. So the reason why we put 2 moles of copper 2 carbonate here is so that moles of copper 2 carbonate can cancel these moles of copper 2 carbonate so that we can calculate the moles for acetyl salicylic acid. So then we will have 0.008 multiplied by 4 divided by 2, and this will give us 0.016 moles of acetyl salicylic acid. So the calculated moles from the balanced equation for copper 2 carbonate is 0.0085 moles, and the calculated moles from the balanced equation for acetyl salicylic acid is 0.016 moles. Out of these 2 moles, 0.0085 is smaller than this mole. So what it means then is that copper 2 carbonate is the limiting reagent because its mole is smaller than the moles for acetyl salicylic acid. So this is how to determine the limiting reagent. The reagent that has a smaller mole is the limiting reagent. So in this case, copper 2 carbonate is the limiting reagent because its mole is smaller than the moles for acetyl salicylic acid. So the theoretical yield is equal to moles of the limiting reagent, which is copper 2 carbonate, multiplied by the molecular weight of the product, which is copper 2 aspirate. So we already determined that the limiting reagent moles is 0.0085 moles. So molecular weight of copper 2 aspirate, this is the chemical formula, is equal to 844 gram per mole. Therefore, theoretical yield is equal to 0.0085 moles multiplied by 844 gram per mole. So this mole will cancel this mole, and we will get that the theoretical yield is 7.174 gram. So now that we have the theoretical yield, we can now calculate the percentage yield. To calculate the percentage yield, you use the formula percentage yield equal to actual yield divided by theoretical yield multiplied by 100. Let's assume that the actual yield is 2.9 gram. We don't know, I just use one value just to show you how to do the calculation. It could be any value, but since this question did not give the actual yield, we just assume that it is 2.9 gram. So you simply put 2.9 gram for actual yield divided by the theoretical yield, which is 7.174 gram. This gram cancels this gram. So when you do this division and multiply by 100, you will get that the percentage yield is approximately 40%. So the percentage yield for this problem will then be 40% if the actual yield is 2.9 gram. Okay, in summary, the steps that are involved in calculating theoretical yield are: step 1, you calculate the number of moles of each of the reactants. Step 2, you calculate the number of moles using the balanced chemical equation, and also using the moles calculated in step 1. Step 3, the smaller mole from step 2 is the limiting reagent. Step 4, you multiply the moles of the limiting reagent from step 3 by the molecular weight of the main product formed. In this our case, the main product formed is copper 2 aspirate. Then the last step is to calculate the actual yield using the formula percentage yield equals to actual yield divided by theoretical yield multiplied by 100. So these are the steps involved whenever you are calculating theoretical yield and percentage yield. Right, this is where I'm going to end for today's lecture. Please like this video and subscribe, and I will see you in the next lecture.